Hello everyone, welcome to the world of physics. Once again we are back with 12th class physics, chapter current electricity, and today we are going to take up Kirchoff's law. We have earlier solved electric circuits whereby we have taken series and parallel combination, but every circuit is not so simple which can be solved in by series and parallel combination. But with the help of Kirchoff's rules, we can solve almost all types of complicated circuits. There are two rules which are there to help you understand how to solve this. These rules are given by Kirchoff's, and as you can see, I've given a short introduction here about Kirchoff. He was a German physicist, professor at Heidelberg and Berlin, and mainly known for his development in spectroscopy and for the Kirchoff's rule. So let's begin with the Kirchoff's rule. This is a general circuit. Electrical circuits generally consist of a number of resistors and cells, and they are interconnected, and sometimes, rather most of the times, in a very complicated way. The formula we have derived earlier for series and parallel combination of resistors are not always sufficient to determine all the current and potential differences in the circuit. So we are going to study two rules which are known as Kirchoff's rules, and they are very useful for analysis of electrical circuits. Let's study the first rule. Kirchoff's first rule is known as Kirchoff's current law, or it is called as Junction Rule. The statement of the first rule: at any junction, the sum of current entering the junction is equal to the sum of currents leaving the junction. Now, what do you mean by that? Here we means, what is the meaning of junction? Junction is a point where three or more than three wires meet. So for example, this point is junction. 2 ampere current, 3 ampere and 5 ampere current, which is outgoing, is meeting here. So the rule says sum of current entering the junction is equal to sum of current leaving the junction. So these are the two currents which are entering, and this is the one leaving. So 2 plus 3 equals to 5. It's a very simple process. And remember the polarity. We have to take current entering as positive, and which is the outgoing current, we take it as negative. Okay. So 2 plus 3 minus 5 is equal to 0. That can be another form of the junction rule. It can be written as summation of I equals to 0. Summing all the currents, this is equal to 0. And it is based on the principle of conservation of charge. This you should remember. It is based on the principle. The proof of this rule follows from the fact that when the current is steady, there is no accumulation of charge at any junction or at any point in a line. Charge cannot be created or destroyed. It has to be conserved. Whatever is the current coming in is the current moving out. It is not accumulated at any point. And this is conservation of charge. Let us take a question to understand it better. In the given figure, find the unknown current I using Kirchoff's first law. The law is very simple. Whatever is the amount of current entering is the amount of current leaving. So solution, sum of current entering is equal to leaving at the junction. So 3, 2 and 4, they are entering, and 15 and I, they are leaving. So 3 plus 2 plus 4 equals to 15 plus I. Solving it, we get minus 6A. Now what do you mean by minus sign? You don't put minus sign in the current. Minus means the direction. It means the direction is not this way, but it is the opposite way. So if I is negative, as in this case, then it means our assumed direction is opposite to the actual direction. It only means this, nothing else. The value remains still the same. So remember, first law, sum of current entering is equal to sum of current leaving, or summation I equals to 0. Let's move on now to the second law. It is known as Kirchoff's voltage law, KVL in short, or loop rule. Why is it loop? Loop is a closed conducting path. You can take any path. You can take A, H, D, C, B, A back to A. This is one loop. Loop means you start from it and then you come back to the same point. You can take the bigger loop, A, B, D, E, F, G and back to A. This is also loop. So you can take loop in any of the directions. Okay. Second law states that the algebraic sum of changes in potential around any closed loop involving resistors and cell in the loop is 0. That means if you take a loop like this, there will not be any change in potential. The potential may vary along the resistors, but if it is increasing at one point, it will be decreasing at the other point. Delta V summation is equal to 0. This is the second law. Delta V summation equal to 0. And this loop rule is based on the principle of conservation of energy. Let's see how do we apply a loop and what is the exact meaning of this statement. Why the change in potential around the loop is 0? I told you, you start from, let me take you back, you start from a point, come back to this point, and I am saying the change in potential is 0. This is the statement. Why? To understand this, electric potential depends only on the endpoints. Remember in the earlier chapter we have done that the electric potential depends only on the initial and the final path. It does not depend upon the intermediate path. So it only depends on the initial and the end points, final point. So if we move in a closed loop or circuit starting with any point, we come back to the same point. Loop means this, you start from one point and come back to the same point. So starting from one potential and you're coming back to the same potential. So there is no change in potential. Hence the voltage drop across the loop must be equal to any voltage source met along the way. That is delta V summation equals to 0. Now this second law is based on conservation of energy. So how is energy being conserved in a loop? See, we have learnt the formulas earlier which we are going to use now. Remember the formula for delta V? It is the work done upon the charge. Remember that. We are going to take that. Now in the loop there is no change in potential, so work done upon charge is 0. That means work done is 0. Charge is not 0. So as the work done is 0, and we have another formula, delta U. It is given as negative of work done. And work done is 0 means U is equal to 0. And when U is equal to 0 means energy is conserved. So the circuit loop is closed conducting path and no energy is lost in it. That means the energy is conserved. So remember, in a nutshell, I will let you know once again. Second law tells you if you go around in a loop, there is no change in potential difference. Whatever may be the potential across resistor, across cell, whatever is coming in the loop, just write it down, put it equal to 0. That is the second law. Delta V equals to 0. Okay, and remember the first law, delta I at a junction equal to 0. Let us now move to the sign conventions. Whether you have to take positive or negative, or what do you have to take. This is for calculation of voltage drop across the circuit elements. This is for second law. Remember for the first law, current entering positive, current leaving negative. And for this, if it is a resistor, like we are taking this closed loop, we start moving, we come across a resistor, and this is the direction of our motion. Okay, and this is the direction of current. If both current and direction of motion are same, we consider it as a fall in potential and we take the potential as minus of IR. Okay, so if the directions are same, it is minus, and if the directions are opposite, that means we are moving this way and the current is moving in the other way, opposite. We are in the path, closed path is like this, current is like this, opposite. Then there will be rise in potential, we will write plus IR. This is for resistor. And across a cell, it's very easy to remember. Cell negative N to positive N. From negative to positive, the potential always increases and it is positive. And from positive to negative, if you are moving like this is the positive end of the battery, this is the negative end, you move like this, there will be a decrease in potential and it is negative. Okay. So across resistor, remember if the current is in opposite direction, we take it negative. If the current and the loop is in opposite direction, we take it positive, and in the case of cell, it is negative to positive, it is positive. Now applying the loop law in the loop. How do we apply it? Okay, how do we get this equation? Listen carefully. Consider the loop A, H, D, C, B, A. Okay, this is a loop. Now in this loop, we are going like this. I'm putting an arrow. Okay, we are going like this. Current is also moving like this. So current and our loop is in the same direction. That means the potential will be negative here. What is the potential using Ohm's law? It is V is equal to IR. The value of I is I1, R is 30. So minus of 30 I1. Okay. Then you move ahead and you come across a battery. From negative to positive, so it is rising. Okay, it is positive to plus 45. Then we have 1 ohm and the current through it is I3. So 1 and 40 also they are in series. So 40 plus 1 into I3. And both of them are in the same direction, so it is negative. And we have the first equation. In this loop, A, H, D, B, C, A. Take another loop, A, H, D, E, F, G, A, the bigger one. In this, you tell me and I am also telling. Let us see, we match each other. The current I moves. We are also moving in this direction, so it is minus 30 times I1. Then we move to 20. Here the direction of current is opposite to our direction. Current is in this direction, we are going in the opposite direction, so it will be plus. And since they are in series, so 20 plus 1. Okay, it is 20 plus 1 times the current is I2. And we go from positive to negative, so minus of 80 is equal to 0. So applying the laws like this, and if you want to solve it, we have equations and solving, and we can easily do that. Let us take a actual question for solving it. These are the numericals based on Kirchoff's law. Okay. This is example 3.7 of NCERT book. The question is, you're given a branch of the network, mesh of network rather. Determine the current in each branch of the network. AB is one branch, BE another branch, ED, AD. These are all different branches of the network. You have to determine current in each branch. Okay. So for that, apply Kirchoff's second law. We have already applied Kirchoff's first law and written down the values of I1, I2 and I3. How I have written? Like this is a battery, current is coming out. We have written I1 at point A, current sees two paths. One is like around this from A to B, another one A to D. So if this is I2, then left is I minus I2 going from this and so on. So applying the Kirchoff's first law, we have put in the already in this given in the book. Let us now apply the second rule for the closed loop. Let us take the loop A, D, C and A. Okay. So let me label it. We are going like this. Okay. This is the way we are traversing. Okay, we'll just put it so that we know the direction. Now start writing the equations. From A, we come across first resistor. Our direction of loop and the current is in same. So it is minus. Minus of 4 times I1 minus R2. Minus of 4 times I1 minus I2. Then we move ahead to the 2 ohm resistor. Again it is in positive. We are going in this direction. Current is in this direction. So it is plus. Plus 2 times this current. 2 times I2 plus I3 minus I1. Then we move ahead and we come across I1. I1 and 1 ohm resistance and our position of transverse is in the same direction. So it is in minus I1. And then negative to positive, so it is plus 10 volts. And we have got the first equation. Okay. Now second loop, A, B, C, A. Okay, you start writing it and let me see whether we are correct or not. A, B, C, A. So A to B, it is I2. Let me put the values first. We are going like this. Okay. Let us write the equation. it is, we are moving in this direction, current is also in this, so minus 4 times I2, minus 4 times I2. And then we move across 2 ohm resistor, we are moving in this direction, current is also in the same, so minus 2 times I2 plus I1, minus 2 times I2 plus I1. Then we move along 1 ohm resistance, current is also in the same direction, we are also moving, so again minus of I1. And then we encounter a cell from, this is negative and this is positive. Okay, so from negative to positive, it is positive, so plus 10. So we have plus 10. So we have got two equations here. Earlier we have done this equation, and now second loop, second equation. Consider the third loop. The third loop is B, C, D, B, E, B. This one. Okay, apply, come across 2 ohm resistance, and this is the way we are moving. Okay. So come across 2 ohm resistance, V, and the current in the same direction. So minus 2 times I2 plus I3, minus 2 times I2 plus I3. Move ahead 2 times I2 plus I3 minus I1, so it is minus. And then we are having a battery whose negative terminal is this and positive is this. So minus 5 to plus means positive. So plus 5 and coming back to B is equal to 0. Okay. So you can see here that we have got 3 equations and 3 loops. Okay. Let me, right. Now, solving this equation, we can get the value of I1, I2 and I3 as required in the question. But the question says, determine the current in each branch, not only I1, I2, I3. So, what do? What is our AB? Is I2. We write the value. So, we write the branch and we write the values. This is the way we solve the question based on Kirchoff's law. Let us take up one more question. Now, this question is a resistance question, cube resistance rather. A battery of 10 volts and negligible internal resistance is connected across diagonally opposite corners of a cubical network consisting of 12 resistors, each of resistance 1 ohm. So we have given a question like this where we have a cube. In the cube, each value of resistance is R. Okay, remember this, each value of resistance is R. Question is, determine the equivalent resistance of the network and the current along each edge. Okay, so this is the question. To understand it better, let's symmetrically understand this. See, consider point, this is the source of the current. Okay, we have a battery here, and this is the positive end of the battery and this is the negative end. So obviously the current flows out of this end, it moves to the point A, and from here it enters the cube. Okay, but see this, A prime, AD and AB, these are symmetric and each of them is having resistance R as given in the question. So this means all the 3 arms have same current I flowing through it. This is the junction rule, Kirchoff's first rule we are applying here. At this junction, the value of current is same, 3I entering and 3I coming out. Okay. This I reaches at the point A prime. At this A prime, we again have symmetry. It goes to AD and it goes to A prime, B prime. So two path I current is divided, each of them getting I by 2 and I by 2. Similarly here, I by 2, I by 2, and similarly here, I by 2 and I by 2. So the cube is very symmetrical in nature. Now from this point, I by 2 and I by 2 combines and gives you I. Here I by 2 combines and BC is I by 2 and I by 2 combines and CC prime is I. So we have 3 I's coming and collective is 3I, which is coming out and going to the negative terminal. So we have a symmetrical cube resistance. So using Kirchoff's first law and the symmetry, we label the current in each arm, just like I told you. Now to solve the question, to determine the equivalent resistance. To determine the equivalent resistance, we take a loop. I'm going to take, you can take any of the loop. You can take A prime, D, C, or you can take A, B, C and C prime. Okay, I'm going to take this one, the simplest one. Okay. So my way is, I'm going around this path. Okay, I'm going along this path and my loop is like this. Okay, draw it like this. So current is also moving like this. I am also moving like this. So voltage drop across is minus of IR. Okay, it is minus sign when both the current and the path is in one direction. One direction. It is minus, and then it is here also. It is minus of half I into R. Again the same direction, so minus of IE, and then it comes out and goes from negative end to the positive, so it is increasing, it is plus E. This is equal to 0, and we get our first equation from the loop law, Kirchoff's second law. Here R is the resistance and E is the EMF of the battery, and when you solve it you get 5 by 2 IR is equal to E, simple mathematics. Now this is our first equation. We cannot write this as R equivalent. Why? Because this is the R resistance. For R equivalent, we have to apply Ohm's law, and this whole thing we have to take as R equivalent. So V is equal to IR. I is 3I, R is R equivalent, and what is V? It is E. So using Ohm's law, we have E is equal to 3I times R equivalent. Now equation 1 and 2 gives you the value of E. So equate these two sides. Equating these two sides, we get the value of R equivalent as 5 by 6R. This we can solve using series and parallel, but it can be solved very easily using Loops law. So the total current now is 3I, total equivalent resistance is 5 by 6R, and EMF is 10 volts. So apply Ohm's law, 3I is equal to 10 upon 5 by 6 times R. We get 3I is equal to 12A. Simple solution of this, and this is 3I, I is 4A, and I by 2 is 2A. So we get I by 2 and 3A. We get all the value of current across the cubes. So you can see using Kirchoff's law, the circuit becomes very simple to solve. It's really easy, just have to make the equations. If there are more than one values of current, make two equations, compare, and then simple mathematics gives you the required things. So I hope you will remember this. The Loops law, it is the conservation of energy, and the junction law, which is the conservation of charge. Sigma I is equal to 0 is the first law. Sigma delta V is equal to 0. This is the second law. I hope you have understood. Thank you.